Hi guys, today we are going to see digital electronics part 1, table of contents. Today we are going to see these topics: analog and digital signals, need for digital signal over analog, Boolean algebra and its purpose, gates and its functions. So let's dive through. Analog and digital signal. First of all, what is analog signal? An analog signal is a continuous signal that varies over time and can take any value in a given range. Like if you see this wave here, the assume like you are having 0 here and 1 here, and between 0 and 1 you can take multiple values like 0.1, 0.11, 0.11, 0.2, etc, etc. This wave is known as analog signal, and this signal is also known as sinusoidal signals. Here when you see real life examples are like human voice. When you speak, the sound waves are continuous vibrations in the air, so it's also some analog in nature. And everything around us is analog in nature, like temperature reading from thermometer. The reading from a mercury thermometer varies continuously as the temperature changes. The mercury liquid is temperature dependent, so it changes accordingly when the temperature increases or decreases respectively. So if you see digital signal, a digital signal is a discrete signal that takes only one specific value, usually represented as zeros and ones, binary. So here in example, see here in this example, it can take any value from 0 or 1, not between 0 and 1. It's only 0 or 1. Like in real life examples or computer data, all information inside a computer is represented digitally as zeros and ones. So computers can't understand English, French, Tamil, etc, etc. So to make them understand what we are trying to say is we are using binary languages, digitally zeros and ones. Digital clocks shows the times in steps, like example 12 o'clock, 12:1, not continuous motion, it is digital in nature. Need for digital signals over analog signals. Why we choose digital signal but not as analog signals? The first reason is noise immunity. Analog signals are very sensitive to noise and distortion. Even a small interference can change the signal. Like if you see in the analog signal which will be sent from transmitter to receiver, the analog signal is 1 volt, means it will be received as 1.5 volt. So 0.4 volt, 0.5 volt, 1 volt means the receiver will receive 1.4 volts. So 0.4 volts additional noise is added to the signal. So in digital signals, it is much less affected by noise because small variations don't change the binary value, because it can vary only either 0 or 1. Easy storage and processing. Digital signals can be stored in memory devices like computers, USB drives, without losing its quality. Analog signals degrade over time when stored. So storing purpose for digital signals are very complex, very easy. Storing purpose for digital signals are very easy, but in analog signals its storage is very difficult. Example, if you see music stored on a CD stays clear, unlike old tapes. In older days we use old tapes to store some data, but it will be less quality. So CDs will not be that much distorted with noise. Efficient transmission means digital signals can be compressed and transmitted over long distance without losses of quality. Analog signals degrade over distance due to attenuation and noise. So if you transmit a digital signal from transmitter to receiver, it will get affected with noise much lesser than the analog signal. Example, internet video streaming is digital, while old analog TV signals could get snowy or fuzzy in TV displays. What is Boolean algebra? Boolean algebra is a branch of mathematics which deals with a variable that only have two possible values, either 1 or 0. It is used to analyze and simplify the logical statements and digital circuits. So if you see in basic mathematics, we do multiplication, addition, etc. So here it can be done by using AND gate, OR gate, NOT gate. We will be seeing it in much detail in later slides. What is binary and its purpose? Binary is a number system that uses only 2 digits. 0 and 1. Each digit in a binary number is called as a bit, binary digit. So if you see the example for binary number, decimal 0 can be represented as binary 0, decimal 5 can be represented as binary 101, 10 as 1010. This conversion from decimal to binary will be explained in later videos, so stay tuned through the series. Purpose of the binary: to represent information electronically in a simple and reliable way, to make computations and logic operations efficient using zeros and ones, to reduce errors in storage and transmissions of data. These are all the purpose of the binary. An example in real life is like, if you type A in computer, it will be stored as 01000001, and a color pixel 24-bit binary code. Now we are going to see detail about AND gate. AND gate is a logic circuit that gives an output of 1 when all inputs are 1. In other words, it works like a condition that must be completely true for the result to be true. See here, in truth table, if you give 0 0, it will return as 0, 0 1 0, 1 0 0, 1 1 1. So in real life example, AND gates are used in a security systems. The door opens only when the correct password is entered and the key is inserted. If either one is missing, the door will not open. OR gate. OR gate gives an output of only 1 if only OR gate gives an output of 1 if any one or more of its input is 1. It performs a logical addition operation. This means the output will be 0 only when all inputs are 0. See here in this truth table, if 0 0 input means it will be returning 0, 0 1 1, 1 0 1, 1 1 1. In real life example, OR gate is used as in a room lighting systems. A light can turn on if any one of the two switches is pressed. If both switches are off, the light remains off. Next comes NOT gate. The NOT gate, also known as inverter, is a gate with only one input and one output. See here in this truth table, if you give 0 means it will be inverted and output will be as 1. If you give 1, it will be giving you 0. Real life example. In an automatic night lamp, the lamp turns on when there is no daylight. The light sensor detects brightness and the NOT gate inverts that signal. So when light is absent, the lamp turns on. NOR gate is formed by connecting an OR gate to a NOT gate. It produces an output of 1 only when all inputs are 0. See here in this truth table, if 0 0 1, 0 1 0, 1 0 0, 1 1 0. Real life example, in street light control, the light turns on only when no daylight and no manual switch is active, meaning when both inputs are 0, output becomes 1. NAND gate. NAND gate is a combination of an AND gate followed by a NOT gate. It gives an output of 0 only when all inputs are 1. In all other cases, the output is 1. The NAND gate is also called as a universal gate, as any other gate can be built using it. 0 0 1, 0 1 1, 1 0 1, 1 1 0. Real life example, in alarm systems, the alarm stays silent only when all safety conditions are met. If any condition fails, the output becomes 1 and the alarm activates. XOR gate. The XOR gate gives an output of 1 only when the inputs are different. If both inputs are same, the output is 0. Here the truth table is given as 0 0 means 0, 0 1 means 1, 1 0 means 1, 1 1 means 0. Real life example, in a smart door system, the door opens only when one signal is active but not both. For instance, when the owner is either inside or outside but not both at the same time. XNOR gate. XNOR gate is the complement of XOR gate. It gives an output of 1 when both inputs are same, either both 0 or both 1. So here the truth table is given as 0 0 means 1, 0 1 0, 1 0 0, 1 1 1. The real life example is in a password checking system. The circuit compares the entered password and the stored password. If both matches, output is 1 and the access is granted. In conclusion, now you understand how logic gates form the brain of every digital system, from your phone to traffic lights. If you find this video helpful, don't forget to like, share and subscribe for more easy electronic lessons. Turn on the bell icon so you never miss the next topic. Next comes K-map simplification and Boolean algebra tricks. Thank you.